For this problem, we are to find V0, V1, and V2. And if we look at our circuit, we'll see that we have a single source and several resistors. So we're going to utilize our problem-solving strategy on analyzing circuits containing a single source and a series parallel interconnection of resistors. And if you remember, our plan of attack here is to combine resistors until we get down to a circuit which has a single resistor and a single source. So if we look, for instance, just to begin, here's a parallel combination, here's a parallel combination, and then really here's a series combination. Okay, so this is 12 kiloohms. The combination here, 10K times 20K over 10K plus 20K, 6.67 kiloohms. And then for these two resistors on the bottom, we have 5K times 10K over 5K plus 10K, or 3.3 kiloohms. So our next step is to redraw the circuit with those combinations. So our circuit has been reduced to the following. And if we look at our circuit, V0 is still on there because that was a voltage across the parallel combination of the 5K and 10K. V1 is still on the diagram because we didn't combine the 4 kiloohm resistor in any combination. Now, these two resistors are in series. These two are in parallel. So let's further reduce the circuit then. Our circuit is reduced to the following. The voltage V1 still across that 4K. We've lost the voltage V0 now because we combined that 3.3K in series with that 6.67K. So now these two are in series, so we can draw our circuit again to reflect those combinations. Now the voltage V1 has been eliminated from the circuit because we've combined that 4 kiloohm in series with that 6 to give a 10. And now we take the two 10Ks, they're in parallel, so our circuit further reduces to the following. Okay, the 5K is a parallel combination of the two 10s. And now these two are in series. So our circuit, where we're reducing it down to a single resistor and source, is this. Now we can calculate the current from Ohm's law. I1 is 16 over 8K, which is 2 milliamps. This current is 2 milliamps. And in this circuit is 2 milliamps. Now if I look, I'm going to have a current divider, and notice that the two paths, once the current here, are the same, so this current's going to split equally. Okay, so there's going to be 1 milliamp flowing to the right and 1 milliamp flowing to the left. So now let's start backing up in our circuit. And we know here we have 1 milliamp in that direction. So we can calculate V1 now. If we look at the voltage across this resistor caused by that current, this is going to be 4 volts, okay, and that's from Ohm's law. So then V1 is minus 4 volts because V1 has the opposite polarity of this voltage, and the 1 milliamp flowing in this direction produces a voltage with 4 volts with that polarity from Ohm's law. And if we look on our circuit, then this voltage is 6 volts, which tells us that this voltage is 6 volts. And also we can calculate the current is 0.5 milliamps in that direction. And also, if we note, we have 1 milliamp here, 1 milliamp here, so we can calculate V0 in this circuit. So if we notice, V0 is 3.33K times 1 milliamp, so V0 then is 3.33 volts. And now we need to back up to our original circuit where we started. We've calculated V0 and V1, and we calculated that this current is 0.5 milliamps. So that means there's 0.5 milliamps flowing at that point in the circuit. So then V2 is 0.5 milliamps times 8 kiloohms, and V2 is 4 volts.